Okay, so I can start now and then others may join in the middle. Okay. So this is week 12 of Foundation of Art Software, and I'm Kamna Mishra from School of Mathematical and Statistical Sciences, IIT Mandi. And this course is taken by the instructor, Professor Salab, who is from Department of Mathematics and Statistics, IIT Kanpur. So these are the usual links for all the classes, problem solving session links in YouTube. So the topics for today's class is are basically firstly, like we have started the graphics in the last class, if you remember. So we have let me show you. Okay, so in the last class we have started from the graphics and the plots, and so we will continue that today. So we will firstly see subdivided plots. So uh, then we will see pie diagram, and after that the combining graphics. So uh, combining graphics are basically, let's say you have two or three or four plots and you want to see all in like one frame. Okay, so that you can sometimes see that, okay, if it is happening in this, you can basically compare your plots. So in that form also it is good. Then we will move to the histogram, and the next will be 2D plots and the 3D plots. So, and in the last we will see some function, how you can like these are the basics. So by the end of this, the all the lectures are completed. So when you will work on your data, or anything, like if you want to work on data or if you want to work on statistics, pure statistics, then also how you can make use of all this. Okay. Okay, so we will firstly start from the subdivided or component bar diagram. So subdivided bar diagram is also like, you can say it like uh, stacked bar plot. So stacked bar plot means, so till now what we are seeing is that we were looking this. So this one, this one, let's say this, and let's say this, and then this. So this is kind of a bar plot. If you will see the axis here, if you will see this axis, so these are also the bar plot. But a stacked one means basically that that inside one, like inside this, you have more information. So what you can do is that you can make one stack. Okay, and let me just there, and then so right, I think then you can have this.
Ma'am, it is not clearly visible.
Yeah, I know, let me change my setting. Change my setting. Okay, so it is visible now. If I remove this, let me remove this also. Okay, so you have this, and then let's say you have this. So what is happening here? You have this one kind of, this one is stacked, right? So you can convert this also in stacked, but if you have like information regarding three variables, and let me use these colors again. And for the next one, it is like this, and then it is like this. So, and the last one is like this. So let's say you have two, let's say one and two. So let's say I want here. Let's say I want to see the sales, okay, of four shops. So let's say sorry five. So of five shops, okay, or let's say the profit in sales. Right? So let's say I want to see the profit. So this one is like this. But in the profit, like you can have the profits from the different sectors. So let's say you are studying regarding a mall. So in the mall, you have the shops of clothing, right? And then like grocery, uh, and then let's say like anything else, okay. So you have one two and three are like let's say from others, okay. So you are getting the profit from three. So now here if I say that I am getting to today, let's say there is like profit in rupees, so let's say I'm getting some 12,000. So I'm getting some 12,000 rupees. Now I don't know that like whether my sale of clothing was good, or whether it was from grocery, whether it was from some other. We don't know about it, right? Or you can consider the movie. So if movie is good, so you will have the higher one from here, right? So if any festival is coming, let's say, so if there is like there was Dashera, there's Diwali coming. So the clothing sale will suddenly grows up, right? So you can have that kind of thing that, okay, so what is my profit? So then you can make use of stacked bar plot. So if you have two malls and then you want to see this, then you can see that, okay, in here for the clothing session, it was this. So let's say it is one and two like this. Okay, and here in this. So the people are more preferring the second mall for the clothing. So similarly this. So we can also see this and then we can also compare all these things. Okay. So stacked bar plot will give you much more information in terms of the normal bar plot. So this is like one example I have given to you. You can think of like several examples where you can use this, or we can you can actually use it in your data. Like if you want to work on a stock data set or any other finance, or if you want to see that car for the cars, for the automobiles, and much more. So you can also divide it state wise. So state wise, like mobile companies, so in this state which mobile they are preferring. So like thousands of the application one can have. And then if I will show you by this, it is like better, always better. If I will give you just numbers, just a table, then graphics are always preferable over the tables, because you don't need to read anything here. You can just see that it is greater than this. You don't need to show that it is greater than this. Okay, so let's see how we can make these plots, right? Uh, okay, so let's say I'm just giving this data, and I am writing this as let's say I'm giving it in P. So P is for the profit of data. Okay. And I'm giving it in the matrix. And here there is 2. So we can take 3 or 4, any number. So let's say n row, uh, n row is 3 and n core is also 3. Right? And the data we are giving, uh, let's say any random 345. Okay, so 2, 4, 6, 8, and 9. So we have this matrix. Okay, sorry, P. Okay, so from here you can see, let me just remove all this. So here you can see that this one is your stack one. Uh, so for the better one, what we can do is that uh, let us change the column 4 so that it will be clear that uh, how it is divided. Like otherwise, you will be confused that whether 3 are this or whether 3 are this horizontal or vertical numbers. Okay, so let me write this as 4 and so this one is our matrix. So what we want now? So all you need to do is that write bar plot of P. Okay. So here you can see that this one is the bar plot. So if you will see that, you can see that in the third one there is the maximum profit. But if you will talk about the profit regarding the second one, then you can see it is in the second. So second one basically means, so let me just put it here. Okay. So if you will say, let's say total profit, then you can see that total profit is maximum in the third one. But if I say that total profit, let's say in, let's say the first one, the second one, the third one, like this, and the first one is grocery, the second one is clothing, and the third belongs to others. So if you will say that maximum profit in clothing, then it is in the second one. It is not in the third one. So while the all the people, so then there can be a lot of factors regarding that. So the factors can be this small, maybe the population near this mall is very high, so that's why overall it is very high. And in the second one, maybe it is like a far away, but when it comes to clothing, you always prefer the best one, so people can go to the second one. So then you can, like, after creating your plot, you can think of a lot many things that why it is working like that. So uh, what I want to say is that what you are learning here is that making a plot, but what you need to do is that take the information from that plot, because making a plot is not a big work, because all you need to do is that give the data, give bar plot, it will give you the answer. but then understanding that data sets inside of the data sets, that is what you need to do for the further work. Otherwise these will be just syntax. This will not give you anything, right? Question or something? No. Okay. uh, Now the next thing is that we can give it okay, so this one is like very base, so nobody is understanding that, like, I am the one who is understanding which one is what, but the other person will not be able to understand what plot is this. So what we need to do for that is that we need to uh, just make it better. So what we need to do is that we need to give the names. So firstly I will give the names to all of this, and I'm writing it as m1. So m1 is basically for mol1, mol2, mol3, and mol4, right? So this one I can give as names. uh, X lab, so X lab is basically X label, so X label I can give as yes, and then Y that I can give as profit. Then colors I can give as uh, red, blue, green, right? So now you have the colors, you know that this one is for mall, so the red colors you can write it. Now here you can add one more like this, that okay, the red color is showing uh, the red color is showing is that the clothing one, and the blue color is this and all, so etc etc. So you can make it like as better as you can, so that the it will be like good for the next person who is actually seeing your plot and trying to understand. So when we write papers, what we do is that this one is the basic, so this one is basically understanding the data. And because what I why I'm saying this, uh, when you work on something na, you will not work it like this, okay, so I will firstly make all these things, and what if you are not getting anything from the data? Sometimes what happens is that, let's say your bar plot is not a very good thing for your data, and if you have done all these things, like given all these things, then we do then it is like your waste of time, because it is none of use. So firstly always start from the basics, so always start from here, and if you think that this one is a good plot for your data, then try to color it and like make the graphics better. Okay, so this one was regarding the bar plot. Uh, the next topic we will see is that pie diagram. So, pie diagram is basically also another graphics, and that one is regarding like here you were getting information, and here also. So, let's say in this bar plot, uh, what happens is that if I have the data of, let's say, just clothing and grocery, and mm, just two, okay, and not for the others, then also I can make this, right? I can make this, there is no issue. But for the pie chart, like it is a circle, so what you have is that most of the time that takes as a whole information. Okay, so you can here, if you have like 30, if I will say in the percentage terms, if you have 30% profit in clothing and 20% in the grocery, you can make it like okay, this one is 30, this one is 20, no issues. But in the pie diagram, we generally make it when you have the data and you divide it into the parts, and you can divide it and then you can complete the circle. So the others will complete the circle here. Okay, so that is very important thing, like what you need to see in your data. uh, okay, and also you need to give like it for one, you cannot make it for all, right? So if one time there is a profit of clothing, what you can do is that you can sum it out. So what are the total profit in the clothing part, what are the total profit in this grocery part, what are the total profit in other areas, and then you need to divide it by the total. uh, okay, so let's say now we have a data, and then it needs to be like the whole one. If you have the whole part, then it is good, and otherwise you need to take the table one. So what I want to say is that uh, if you have the total, let's say in clothing you have 43%, and in the second one you have, let's say, 27%. So this one is 7 3 10 and 4 to 6 70. So if you have this data 30%, then you can make, or otherwise you need to have this common one. So common one means like uh, you need to have the data, like you can give it the numbers. So 1 1 1 2 2 2 and 3 3 3. So how many are there in one? So you can also divide it like in like with how many times we are having profit in one, how many times in two, etc. Okay, so let me define a number, just p1, and then I'm dividing it by this. Okay, so this one you can also think of like uh, regarding the mall and regarding the customer review. So let's say I'm having a list of 30 customers. Okay, so this is very small. So you have, let's say, a sample of 30 customers, and based on that, what you want to see is that okay, overall 30 customer are saying this. Then we can see that okay, whether is a like that is a different thing, whether it is a good sample or something else. So in that you can see that I have uh, 4 malls, and then in general, let's say for just clothing, so which customer is preferring this. So I have 30 customers. So let's say 1 2 3 up to 30. So one can pick the first one, other can pick the second one, third can pick the third one, I mean 30th can pick the first one, so etc etc. So they can pick this, and then we can see that how many customers are preferring one particular uh, mall for their purchase. Right? So let's say I'm making some data randomly. Sorry, up to 4 we have. Okay, so let me just see what is the and okay, I don't need to see that here. It will show here, I think. Okay, so right now it is 25. 1, 3, 4, 1. Okay, so we have all the list of customers now. So now if you make this just pi of p1, then it will not make any sense, right? Because it is what it is doing is that it is just saying that okay, 1, 2, 3, 4, 5, 6, 7, 8, and even it is giving according to the weight, like 4 giving more weight to the 4. So 6 1 is 4, so it is giving the more weight, but it is not the case. We are just referring the most from this number 4. So now what we need to do is that we need to take pi table of p1. So now you can see that 1, 2, 3, 4. So here you can see that okay, for the first one, I think it is maximum, and uh, then for the second one, for the fourth one, it is the least. So here, from here you can see that okay, the first and second, third and fourth are divided like this. So this one was regarding your pi. So table basically gives us the frequency of that data. So the frequency matters. And then if you want to change the color, it has already colored it. So if you want to change the color, you can again give the color here. Like okay, this one is the color. So the another other thing what we can do is that we can use the main, and I can write customers if you on uh, choosing more, right? So this one is main is basically for the title of this plot. So you can see that what are the customer review. So in that way you can understand your data. Okay, so we have seen this subdivided bar plots, and then we have seen the pie diagram. The next one is combining the graphics, right? If you have any question, you can ask whenever like you feel needed, and then that's it. Also, if you are taking some time to observing those things, and then you want to ask it later, then also it is fine. Okay. So combining graphs, I already told you. So combining graphs is basically we want to combine two plots. So not combining in that way. Combining is basically seeing those plots in one. Okay. Let's say I'm writing here. Okay, let's say for whole, I'm saying. Okay, so this one is for whole. So you need to do is that you need to write per, and then you need to write mf row equal to c 2 1. Now 2 1 is we are saying 2 rows and 1 columns. Let's say I have done this, and this one, let me copy it, paste it here, and then we copy this and paste it here. Sorry, I have cleared these variables. That's a problem. Let's say 2. Okay. So I have written here 1 and 2. So that means one column, two sorry, one row, two columns. Okay, like matrix dimension. So matrix dimension is basically row columns. So if I will do it here, okay, here I think, okay, then you can see that, okay, this one is the first one and this one is the second one. So if overall you can see that that overall profit what I'm getting from the third one, right? But if I will ask from the customers, then then the first one is more chosen, even when we are not getting the more profit. So what can happen is that they can have the sale, uh, right? So if there is, let's say, 25% sale, right? So if 25% is off, more people will choose the first one, but their profit can be less. Or what can happen is that this one is not a very good sample, because 30 sample, like, I don't know, around 4,000, 5,000 people go to the mall every day, most probably. I don't know, I mean, we don't know the exact number, but there is a high number. So just by 30, we may not be able to understand about the everyone's thinking, right? So it may happen that it is not a very good sample, and then we cannot extract all the informations regarding it. So in that way you can understand this. Okay, so this one was like a combining. Now again, if I will just uh, change it to 2 and 1, then it will come like this. So here, if I will write 1 2, then it will be 1 2, and if I will write this 2 1, then it will be 2 1. If I will write 2 2, then we need 4 plots basically, and then it will be. So you can take according to yourself that how many times, but always remember one thing, that once you are done with this, okay, once you're done with this and you do not want any more of like this, I mean, you don't want any of plots uh, in combining plots, then always do this, that change it to one in one. So one in one means it will be one row, one column. That means it will be the usual one. So if I will not plot the bar plot P, it will come into one by one, right? Okay. So we have covered three topics till now. The next three topics are like a histogram and then 2D and 3D plots. So firstly, we will go to the histogram data. So histogram is basically based on idea of categorizing. So it is basically when you have the data, like continuous data kind of thing. So histogram is basically, let's say you have a data which have, let's say, 1,000 rows or columns. Okay. So in the bar plot, in the pie diagram, what we have is that we like in the pie diagram, you say that you have 1 2 3 4 etc. You have the values. In the bar plot also, you know the values, right? So here if I'm plotting this, I'm having 1 2 3 4 5 values. If I'm plotting this, so I'm having 1 2 3 4 5 6 values. So I'm having in total 6 values, and then it is plotting on this. If you have, let's say, data of 1,000 values, okay, and the data is continuous, and then you want to plot it. So how you can plot it? If you will try to use the bar plot, then in the 1,000 values, uh, uh, let's say in your 1,000 values, uh, you have the data uh, from, let's say, up to 0 to 1,000. Okay, not in that way, 0 to 1,000, not in, like, let's say in 0 to 100. Okay, you have the data from 0 to 100. So all of your data is in between 0 to 100, but the values can be like 0. 0.2, 0.3. You can have values like 10.5, or you can have different values, or let's say even if you have 0 to 100 values, you are not able to plot it. So histogram is basically, what happens is that uh, you have learned in the time of frequency data, you have learned that, okay, the table is what table does basically. It gives, okay, if I have the data which have unique values, let's say 14, 19, and 20, and let's say 14 is 5 times, this one is 10 times, this one is, let's say, 19 times. If you have this data, then you can plot this frequency, right? But if you have a data uh, where you have 14, 14.5, you have 15, you have 15.2, and then 17.3, and then 17.8, and suddenly you have 22.3, and then 24.9, etc., etc. If you have this kind of data, then we cannot create a bar plot, because it will create a bar plot for each and everything, because it is repeating one time. So it is one. But 14.5 one time, this one is one time, this one is one time, so you are not getting anything. So for that, what we do is that we create class, right? We all have, I think, studied when we have seen, uh, I don't know, in statistics, in the basic of statistics, you know descriptive statistics, we know that what we do is that we divide the class intervals. So in the class intervals, what we take is that we take a class interval from 10 to 15, and then 15 to 20, and then 20 to 25, and then inside this we see that, okay, how many are like now. So now 10 to 15, you have these values, to these values, then you have this, and then like exact 15, you take, like, you do not take, I think, in one, or you take from, like, whether you will take it here or here, you do not take it repetitive. Okay, so then you can see that, okay, from here up to here we will take like this. So that way we divide the data, and then that is like base of the histograms. The other things, so that we call is bins. So when you will work, let's say you have the 1,000 data threads or 10,000 data, like, then you can divide it into the number of bins. So number of bins is basically number of classes. So if you will divide your data in 10 classes, you have the less information. If you will divide it into 20, so class intervals are less. So here, if I will say I have four values, so I don't know that whether it is within between 10 to 11, 11 to 12, 12 to 13, and 13 to 14, or 14 to 15, in how many intervals. But let's say if I will divide it into two, uh, let's say here it is frequency 4, but I will divide it into two equal, I don't okay, if I will divide it into two, and then I will try to see. So if here it is 3, it is 1, then I have more information that when it is smaller, it is higher. So in that way, you can see that how many, in how many numbers you want to divide this, and then further what you can do according to yourself. Okay. Okay, so the basic of histogram, like, you can write from here. Okay, so hist, you can see that his x, and then uh, what is the frequency, what is the this one, whether you want to include the lowest one, what is the color, so you can give the color, you can give the main, and then x limit, you can see that, okay, I want to give this one a x limit. So x limit and y limit, you can see that if your that like plot is moving too forward, or if you want, let's say I want the only information when data is in between 10 to 30, and I do not want after that, so I do not want what is happening after 30. So then you can change the x limit, y limit, you can change x lab, y lab, etc., etc. So that all these works can be done according to your data. Okay. So okay. So now, if I will take data, let's say P2 I'm taking, and this one you can consider a data of let's say how much one is spending uh, on the shopping today. Okay, so that can start from zero and up to thousands and all, but we are, let's say, considering, let's say, we the minimum one is, let's say, 150 around, and then up to 250, because like for the normal, like for the daily one you need milk and like vegetables, etc., etc. So you will have a minimum of purchase kind of every day. uh, so let's say these are some values. uh, okay, so let me see. uh, okay, so till now it is 22, and let's say we are doing up to 40, let's say. Okay. Okay, so right now it is 29. That means it's still one. So let's say this is also 30. So this one is also 30. Okay, so now you know that if I will draw a bar plot, it will not work, right? Because if I will try to do bar plot of P2, sorry, you can see that it is not helpful. The pie plot will not helpful. The table will also not work uh, because the table, what, for like there are just two numbers which are repetitive, so this one is not working. And then we can make use of histogram. Okay, so now you can see that, okay, in 100 to 200, there are very less number. 200 to 250 and 250 to 300, there are a lot of numbers, like basically good one. And 300 to 350, this one. And then 350 to 400, again less. Right? So in this way, that is where like histogram comes, so that way you can make use of this. uh, Now in histogram also, uh, like package help. So in histogram also, what you can do is that we can take x lab as, let's say, daily purchase, right? A daily spend money, daily spend, right? Then y lab will be, we can write, sorry, X lab we can okay. Y lab will be number of people, right? And then uh, the main you already know color, we can write it as blue. So if I will do this, so it is not looking very nice. So you can also see that. So what we can do is that we can do give this and we can write density is equal to 2. So density is equal to 2 means it will just give this line. So then you can increase this density. So now it is looking in a cut way, right? Let's say I can increase, let's say 1 to 10, do this to 60. Okay, so now this one is like different. So then you can see that okay, it can be like this. Okay. Also, you can make use of then other things. So what are the other things? Here you have X's are true. We know that plots and then labels. You can give the labels. It's also uh, of the plots and then the angle. So angle is right now. Uh, you can see that it is kind of 45. So if I will give angle as let's say 130, then it is like opposite of this, right? So if I will give exactly 135, so you can see exact opposite because it is 90 plus 1, so 90 plus 45, so it will be 135. So that also you can change. So you can, I mean, play with your graphics as you want, so that because when you like try to write it and then present it, then it is always good to have the plots which other people are not making. So even if you are trying to do very minor changes, then also it is good. Okay. So the next one is that bivariate and then trivariate plots. So this one is that you can see that I have only given this one kind of data. So it is basically this one is 1D array, right? This P2 is 1D array. Now if I want to see the uh, between two of them, right? So. Then we can make use of a scatter plot. So how they are scattered. So let's say here P1 and P2 both are of these values. So or we can make, let's say, P3 and then sequence from 30. Okay, but sequence will be a term which will not be a random one. Okay, so we do not want something which is not random right now. So if I want to do this scatter plot between this P1 and P2 because they have the same one. So let's say I want plot P1 and P2. So what you can see is that uh, here you have P1, P2, sorry, 1, 2, 3, and then 4. So it is like it is not making any sense. So let us try some new array. So this was regarding the daily spent. Now Now, what you can do is that monthly spent data. So, whether let's say you are having one day, so what you can see is that whether there is high chance. Okay, so you can see that whether you have very high chance or not of whether, like, if a person's daily spend is high, there is high chance that their monthly spend is also high, right? So what I can do is that, what I can do is that firstly, I can do this. Uh, I can save it in P3. Sorry, P3, and then uh, I can write just P2 times 30, and then what I'm doing is that I'm adding, let's say, P4, and then I'm adding a new array, T 45 165. Okay, so now you know that if it is 3, then it will be added 1 2 3 1 2 3 1 2 3, right? So we want like more of this. So 35 167 189 1T 230 498, and then 50, then 59. Okay, so it is not multiple right now. uh, Let me just write it separately. This. So length of A1 is right now 12. So let me make it up to 15, right? So okay, so now we are having P4. How I have made it, I have firstly multiplied by 30, and then I have added sum. Okay, so now P4 is one random array you have of monthly spent. So now if I will plot P2 and P4, then you can see this kind of this, right? So it is no, not exactly equal, because what I have done, I have added very small numbers, right? So it is just change of one. So you can see that, okay, so if this one is monthly, this one is daily spent, and this one is monthly. So the person whose daily spent is less, then its monthly spent is also less. Now if I will try to add some numbers bigger for some, not for all, right? If I will do this, then you can see that there is a change in plot. So for here it is change here, and then a little bit. So in that way you can see that, okay, so like right now I have created a data right now, but you can see that, okay, in this way we know that, okay, so if daily spend is higher, then the monthly spend is also higher, but then it can change sometimes. Like it is not always a 45-degree angle, it can be a little bit different. Like from here, this was is daily spent is higher, but the monthly spent is less. For this one, it is daily spent is less, but the monthly spent is higher. So for that you can consider, like overall it is the pattern, but it can be a little bit different. From here also you can see, and then here also. So in that way, you can think of bivariate plots. Okay. So this one is 2D plot, and then next we can move to the 3D plots. Uh, yes. Before moving to the 3D plots, we can see that various kind. Like this one was just a scatter plot, and now we can see that the various plots type, right? So we can see that in different types how it uh, work. Okay. Yeah, you can say whatever you have.
Ma'am, I have a small doubt. When we are plotting histogram,
Hmm.
especially like absolute and relative frequencies are there, na ma'am.
Uh, uh, just a minute.
Okay.
Yeah, say.
Ma'am, while we are plotting the histogram,
Hmm.
we have absolute as well as relative frequencies. Okay.
In the time of bar plot, actually, we have yes.
Okay. And can we, that means while we are plotting the relative frequencies, why don't we take the command table command like we are using directly, we are using the vector and we are giving like frequency equal to false. So in the place of frequency equal to false, why can't we take a table command?
Uh, uh, can you say that from where you are referring this here?
One second now.
This one is histogram. So
Yeah.
bar plot. If I will try. Okay. Yeah.
Okay, ma'am. Okay. It's clarified. It's clarified, ma'am. Thank you. From your code, it's clarified to me.
Okay. Okay, great. So the next thing we will see that okay, we have made one plot, and then you can like try different plotting ways, right? So what we can do is that we can try P2, P4, and then we can give different types. So the type can be L. So this one is not looking very nice. So you know that you don't want this. It can be S. So this one is also very complex. So S is basically this one, and then it goes to this, and then next, and it is like complex. So you don't want this also. If I will write B, then that means the scatter one and the line one both. So these are like different types. If you will write H, so H1 is still better. So but it's still like H1 is still not like it will help you at least in understanding that it is going on a line like it is like when it is increasing, this one is also increasing. But for like uh, our plot, you can see that okay, just this one is better, right? Okay, so this was regarding this. The next what we can do is that we can take pairs. So pairs is what it is doing is that it is taking one time this one uh, in x-axis, this one y-axis, and here it is doing this one is x-axis and this one is y-axis. So that you can take like you don't need to change it here and then you can see it. Uh, what more thing, pairs are basically used when you have 3 to 4. Like here you have just two variables, right? So if you have only two variables, then pairs are not working so well. If you have let me do, like, if we can combine uh let's say three also. Okay, so now you can see that pairs are is working good. So why this one is from P2 and P4, right? P2, P4, P3. So this one is P2, P4. This one is P2, P3, and then again like this. So these values, like this is consider it as a symmetrical matrix. So in symmetrical matrix, what we have the diagonals, and here we have this uh like this one is A11. So A12 and A21 will be the same one, right? So in that way, when you have 3 to 4 plots, because sometimes what we have is that we have sometimes 9 variables. So like I work in climate data, so sometimes I have, let's say, precipitation, temperature, minimum temperature, maximum temperature, sea level pressure, wind speed, etc., etc. If I have 9 to 10 and I want to see that how one is, like if I am changing first one, then how that other one is working, so how they are jointly connected. So in that way, when you have 3 to 4 variables, this one it works better rather than this, right? Because this one, you know that once you have made one, it is not needed to make this plot. Once you know the scatter plot, you do not need P2 and P4 in the box, and you do not need this scatter again. But if I will do this, then I can see how they all are interacting with each other. So this one is matrix scatter plot for 3 variables. The other one is that is smooth scatter plot. So smooth scatter plot is basically, let me firstly draw it and then I will explain. Okay, so a smooth scatter plot is you can see that this one is right now a straight line, which so we can see that LTY is equal to 3. Okay, so
Ma'am, I have a doubt.
yeah, say
Is it possible to take, like in this diagram, okay, what we call it as like smooth in this diagram? Is it possible to take star marks in the place of these circles?
here.
Yes, ma'am. Here, yes, ma'am. Like all, like wherever you find circles, can we take star mark or dot? Like I just want only a dot.
Yeah, I think if I will just do this. No. Okay. You need to. I told you already in the last class, I think, that you can see the command if you want to change this. So in our graph library, like I do not remember each and everything. So there you can see that we can make a star mark, we can make a triangle, we can make a square. For
Okay, ma'am. Okay.
everything, there is a like, oh, there is command for that. Okay. So right now, what I want to say is that scatter dot is smooth. So when you try to do scatter dot is smooth, this is very important. So right now, what it is like, uh, you see that scatter dot is smooth. It is creating a line. Okay. Uh, if I will, I mean, there is very high chance that when you make this kind of plot, then it will be related to the regression line. So regression line, those who know it is good, those who do not know, what we need is that when we try to do regression, so regression is basically done for what? So when you have x and you have y, when you have two variables, and then so when you have two variables and then uh, uh, Okay, Surekha, if there's no question, then please mute yourself. Okay, thank you. Okay, so what I want to say that when you have two variables, you have the data regarding two variables, you always try to forecast the things. So let's say right now I have the data of 50 years, and then I want to see that what is going to happen in 51 year, right? Next year, that means. So if I have a data of, let's say, stock market, let's say of 1 month, then I want to know that what is going to happen uh, in the like first day of the next month, because why would anyone spend if they do not know anything? So when you see that whenever you see spend on any kind of stacks, then it always shows some graph. So it will show that 5 year return, what is their 5 year return, what is their 3 year return. So if then there is calculate, you can calculate according to that. So if you do not know anything about that, nobody is going to spend money. So if you are even in a business or anything, if you want you you want certain kind of profit, then you want a forecast of that thing. So it is not going to happen that it will always increase. So right now it is like, if I will take this plot, it will always increase. So in the real life it is not very easy, but then regression life helps in that. So that way you can take scatter dot smooth to understand your data, that how it is going further. Okay, so the next is you have this three-dimensional data. So I don't remember whether I have library for that. So let me just check it.
Ma'am, I have a doubt.
Yeah, sorry.
Ma'am, for this graph, okay, for this one, like you have drawn the smooth graph, ma'am. That what is the relationship of that graph, ma'am? Like we have some relationships, now, ma'am.
Yeah. So what is the relationship basically? So you can ask that why it is not going from here, why it is not going from here. So
Yes, yes, ma'am.
okay. So let me take it and we can discuss it separately from here. Okay. So if you see it here, so you can see that why it is not like this, why it is not like this, or anything else. Okay? So why it is like this only. So this happens is that it firstly tries to cover most of the points. Okay. First reason is that it tries to cover most of the. If you will try to take it from here, it will not cover all. You cannot cover all, and then it will not be a line. So okay, so a smooth curve firstly. Uh, the next reason is that even when you make, let's say you do not have any points on the line, then also what happens is that, let's say I have a data like this part. Let's say I have a data, and then I have line like this. So right now you can see that there is no point on the data. So it is not covering any of the points. But uh, so regression line says that you will always try to take that line from which uh, if you will take this distance, okay, this distance. So I can make thousands of line. Okay, so here I can make thousands of line, but we will always take the line from which this one xi minus x bar whole square will be least. Okay. So in that regression, we take this line. I don't know whether the smooth one also take like this, but it also works on a kind of similar principle. So we take so that it will be the least one, so that it will always better. So if I will take this distance, this distance, this distance, this distance, and all the distances, and then I can calculate this. Okay, so let's say this one is 1.5. Then I can create one more line. So now uh, remove this line. Now, if you will see, uh, okay, let me remove this. Let me remove all these. Okay. Okay, so if I will take line like this, then you can see these points are very near, right? These points are very near and these points are too far. If I will take line from here, then you can see that this point is very near, but this point is way too far, right? Extremely far. So you can make thousands of line and then you will choose a line for which this one is minimum. So it is not regarding just one point. It will be like the total of all of it. And why we take the square so that it will not be negative. You can also take this one, the absolute value. So that is why we take a particular line. So that is why it makes a particular line a smooth dot curve. Yeah, I hope it is clear. If it is not, you can ask again.
Ma'am, is the graph belongs to strong positive linear relationship, ma'am? This graph which you are showing now.
Yeah, you can say exactly. This one is the positive relation, and then exactly like, okay, so when this is increasing, this is surely gonna increase. So, kind of, so you can see that most of the points are here. So, you can see that most of the points are in line, right? So, it is gonna happen like there are some points which are not here. So, you can say that 90% of the time there is very high probability that it is gonna like this.
Okay, ma'am. Okay, thank you.
And
Thank you.
because all are above this, because why? Because I have only added it here, right? So when I have made this P4 of monthly spend, I have only added here. Okay, so if I will, let's say, do some negative, so if I will do some minus 230 and then minus 160 and let's say minus 189, if I will make like this, then uh, and then I do this, then you can see that some points are below also, right? So in that way you can understand. Okay, so now I need to install this package. Firstly, scatter plot 3D. So now I have this scatter plot 3D, and now we have the data of monthly, and then uh, daily, and then let's say yearly. So yearly one, let's say I will say P5, and then I'm writing it P5 as let's say P4 times 12, and then what I'm doing is that I'm creating 182 so that I can again do this plus minus, and I'm doing it less now. So let's say 450630 minus 1340, and then 1500. So you have the data of 30, so we can take uh, 1 2 3 4 and then 5, let's say minus 1300, maybe 10 will be better. we have 1, 2, 3, 4, 5, 6, 7, 8. Nine. Okay. So let me just write it as yearly. So I'm writing it yearly as B5 plus B2, right? So we have yearly data. Let me write monthly one by B4 and my daily one by B2. Right. Okay. So we have this, and now if I want to plot it, scatter plot 3D, and I want to plot daily, monthly. Then this one is your uh, daily, monthly, and yearly. So you can see that somehow or somewhere like it is like kind of increasing, right? So when daily, monthly, and yearly, so this one you can see that it is in one kind of thing, right? And then you can change its angle. Let's say I want 110. So you can change from, so you can look it from here. Then you can change it 140 or anything like according to yourself, whatever angle you prefer. So you can see it from here. It is 120. Then also, so you can see from here how it is working. And then you can change the color also. The color of it can be blue, can be something else. Okay. Uh, so these are some plots. Then we can have the contour plots, uh, and then we can have there is called pers. So this one is regarding the perspective surfaces of an XY plane. Okay. So this one is basically when you have the tree and then the contour. So let us see the contour. So contours, you can see that you can give x, y, z. So if I will write it here, so if I will just write contour daily, monthly. So it is writing is like that we need the increasing value of contours in x and y. So yeah, you need one. So that is why we want a sequence kind of thing. So what we can do is that we can do sort. We can write it here. So this one is not regarding this. I mean, if you will see that it will not give you the result regarding what we want. So I have given the sort. What is the problem? Okay, so maybe there is some kind of there is some repetitive value. Is there? I will write this sort monthly. Okay, so Okay, so there is one repetitive value at 230. So that is why we need the values which are exactly increasing. Okay, so let us just take one sequence from here 0 to 1 and then, or let's say from 150 to 250 or 400, and then length dot out is equal to um, 30, right? And the other one also we can take, let's say 1500 to 4000. We want length dot out to be 30. This, sorry. So no proper Z matrix is specified. So we have not specified a Z matrix. Okay, so Z needs to be a matrix here. I think it will be like 1, 2, 3. And then we want to take Z as uh, okay. So what we need is that we want Z as a matrix. So we need to create a 3D matrix. And for that we need to have some kind of function. So uh, let's say f is equal to P2 and P4. So we can take function of x and y, which is equal to, let's say, P2, z is equal to after we can give it, need to give it here x and y, and then we need to write okay. So what it is saying that dimension is not matching. Okay, so we will create it separately. So we can take x and y. You have as this. What is the problem here? Pi to 4. So there is the length is 30. We have x and then we have pi, and then I want to create z from this, and then I'm writing this. Dimension product do not match. Okay, I don't know. There is, what is the issue here exactly? Return x as function this x is x square. Okay, so I don't know. There is some problem with maybe with the outer, so we will see that later. Okay, so I will see. I mean, I will see in the next class. So, as I told you, there will be a one class more after that. So, we will look into that later. The next one is that I've said that there is the first one. So the first one, so we can see first. So this one is also the same, I think. So we need to give the s, x, and then we need to give the y value as sequence of 0, 1, and then I'll close this, and then z again as a matrix. So the matrix, I don't know why it is not creating well. Uh, what if I write x plus y? Okay, so because I think the star mark, it is not working well. Okay, so I will write this here. So you can see that this one is the contour plot of this. So contour plots are basically, okay, I will write contour here again. Contour. Uh, so so here you can see that these are the other things we can give. So we can give the color. So if I will write color, let's say is equal to red. So then it will create red. But if you will give a color list of all like 1, 2, 3, 4, then or color list like a rainbow or something, then also it will give according to that. So let us try if I what will happen if we will give two colors. So if I will give red and then blue. So it will be red blue. So if you want a contour with a lines like different lines, then also you can create in that way. Okay, so this was regarding the contour. Uh, okay, sorry, I have not closed it here. Okay, so the similar one, so you can write. Okay, so we can similarly take. So let me just change it with this 1500 and 4000. Okay, so you can see that this one is the uh, this one is basically a plot, 3D plot, and if I will write theta is equal to 30, then it will change its angle. If I will write phi is equal to 30, then it will increase or decrease. If I will write expand, then it will expand accordingly. Right? So here, because I have given the function x plus y, so if you will give some better function, then it will create a better version of it. So let's say I want a square root of x square y square, and then I'm making this plot. Then it is like this. So according to whatever you will give, it will change. Okay. So the more tough you will give, the more better it will look in that way. Okay. So this was regarding the plots. Uh, the last one is basically the exam or the programming of the function. So function is basically be as you can see here. So function is you can define in a tough way. So after that, this I mean after this work, when you will work on your data, then you can see that how you can define a function. So you can write it here like you can say that whether this one is function of what is square root of x square plus y square. So this one is r is basically the radius of the circle, you can see, right? So in that way you can see, and then you can define the summation, so by sum, the product by product, etc etc. So you can take the like large function and then you can find it. So let's say when I work on distribution, so I need to create a function of log likelihood. So log likelihood will contain what is the number, and then x or y, what is the parameter. So let's say you have a normal distribution, right? So normal distribution, let's say 0 comma 1. So then you need to define its log likelihood, right? So the ptf, you can define p to the power minus z square upon 2 1 upon under root 2 pi, and then sigma square z etc etc will change, right? So then you need to define its log likelihood. So it will come, only z will come, n will come. If you will take n mu sigma square, then its pdf is 1 upon under root 2 pi sigma e to the power minus x minus mu by sigma whole square 1 by 2, right? So in that way you need to define, so you need to define your function as sigma x mu and then n in the time of log likelihood. So in that way you can define your function separately and then you can work on that. Okay, so let us take some examples from today's class. So this one is one example that if the number of patients taking a regular medicine is given by n, this then which r command will return the bar plot. So this one is I think very basic. So for the bar plot, because there is no repetition kind of thing. Yeah. So we need this. Sorry. Right. Even correct. The next question is that suppose you roll a dice 20 times with a sum of numbers on the upper faces recorded. Then which R function is used to create a histogram? So it is already saying that a histogram. So histogram of absolute frequency of the sums.
B.
Is it B?
Yes, ma'am. B. B.
Okay. So what is happening is that you are rolling three dices. Let's say 1, 2, 3 dice, and then you are rolling 20 times. Okay. And then the sum of numbers on upper faces are recorded. Okay. So which R function is used to create this? So what can happen is that 1 to up to 6 number you can have in this, right? So the minimum one can be 1 1 1, the maximum one can be 6 6 6, right? And then uh, you have the sums of this. So you have the sum of data. So it can be minimum 3 and it will go up to 18, right? 6, 10. So it can be 3, 4, 5, 6 up to 18. Up to 18. So this will be your sum of data, right? So we will want the histogram of this. So why you have said 2, the B part, I mean. Because in the B part, you can see that there is 18, 17, 12, 12, 13. So why is that? I mean, because in general you can have, you will have a data, right? You will have some data, and let's say in 3, and then you have sum of data. So that sum of data will be some, let's say 3, 9, 12, 4, 8, etc., etc., right? And the length of it will be 20, because it has dice 20 times, right? So it will be histogram of sum of data. Okay, so this one will be the correct one, because what we want to do is that the data we have, then we will take the sum of these data, and then we will see this. Okay. Okay, the next one is that if the sales over this, so here you can see that you can take the histogram of this table, right? Because you can take this frequencies over 20 days. Okay, so I don't think this one is correct question, because you do not have all the data here. You have 20. You have only 10 data sets where it is saying that it is giving over 20 days. So let us just remove this question. So it is saying that from which you can create this scatter plot. So if when we use this L, right? So when we are not giving anything, you can see that if I will give L, then it is giving me line. If I will write uh, like S, B, S is giving me like this, H is giving me like this, and B is giving me like this. So none of the answer is correct. So the correct answer is basically when you just give this X, Y, and that's it. If you do not give, then it will create the scatter plot. Anyways, like plots are all. Okay. This one is which our command will generate pie chart with the title sales in shop based on a vector sales 1 2 3.
Eight.
Okay. So you have pi and you have sales, so it will be 1 2 3 because there is no repetition. If you have the repetition here, if you have, let's say, in place of this, if you will have C 1 2 2 1 3 1 2, then you can create this. Now, but also, uh, you, if you will write pi says, uh, so there is some kind of like ambiguity here. So if sales is like kind of in percent, it is given like 10, 20, or 30, then the right one will be like the first one. But since it is not given, so uh, that means for the one frequency is one, for the two it is one, for the three it is one. So consider it is here. So sales is shop if it is 1, 2, 3. So I think we can consider it as numeric value. So then this one will be right, right? But if we will consider that sales in different shops or number of shops, then we need to take the table one. Okay. Okay, again, it is not correct. I think. Okay. Next one is that which one will plot the multiple variable pairs of x, y, z?
A.
Okay, so what we need to do is that C bind is basically done uh, to combine all of this x, y, z, and then after combining this we will get this. Okay, so this one is that which what function is used to obtain the square root of sum of cubes of three numbers? So sum of cubes of three numbers, that means x cube, y cube, and then z cube, right? So you can see that here it is firstly summing it up and then doing the cube. Here it is cubing and then it is after doing that zero point 0.5, and then here there is no cube. So the first one will be the right one, right? Oh, wait. There is a square root of sum of cubes
Yes,
of
ma'am.
three. So this one. So here also uh,
Option C.
you have x
Option
cube,
C.
y cube, z cube, and then zero point 0.5, and then you are printing this. And here you are taking this and then taking the square root separately and then printing the f2. So what it is doing in the first one, it is doing this part, it is saving it as f1, and then it is taking the square root of f1 in f2 and it is printing f2. Here it is doing all these things in one point. So I think both of the answer will be correct. So the A will also be correct. Then this one will also be correct. Because it is taking XYZ and then it is like I mean both are doing this, this one is doing all in one step, and in this we are just dividing the steps, right? The last one is I don't know, there is again the scatter, so you need to do is that make the
B.
plot one xy. We do not use, I think, scatter separately. Yeah, there is nothing like a scatter separately. You need to do this for a scatter plot. Just plot. Okay. So this one I have told earlier. So let me just remove this question. Okay, so these are all for the today's class. If you have any questions regarding this class, you can ask. And if you do not have any questions, then I will end this class. Oh my god.
Ma'am, your voice is not coming.
Yeah, I have actually lost the network. So okay, so I have a kind of stop. I don't know what's happening. This again stopped.
Ma'am, your voice is not coming.
Yeah, just wait. Uh, there's some issue with my network. Okay, so now I will end the class. And okay, so thank you for joining.